Good morning, grade 9 students. This is Miss Pamela Teeny giving the physics course. Hope you are all doing well. Today we are going to continue chapter 5, section 1, Newton's laws of motion, page 155. So please open your books and follow up with me. Now we are going to continue the section. We already took Newton's first law of motion, Newton's second law of motion, which both relate acceleration and force. So they relate motion and force. Now, in Newton's third law of motion states that for every action force acting on an object, there is a reaction force acting on a different object. The action and reaction forces are equal in magnitude and opposite in direction. So, in summary, for every action force, there is an equal but opposite reaction force. This is Newton's third law of motion. In the figures shown in front of you, you can see two examples of action-reaction forces. To the left, you see if you push the wall with your finger, there is the action force of finger on wall, and there is the reaction force of wall on finger. They are equal in magnitude and opposite in direction and acting on different objects. The first force acts on the wall, the second force acts on the finger. To the right, you can see another example of action-reaction forces. The action force is you pushing on the ground, and the reaction force is the ground pushing on you. They are also equal in magnitude and opposite in direction and acting on different objects. The action force acts on the ground, and the reaction force acts on you. Now we are going to do a comparison between action-reaction pairs and balanced forces. The similarities are that the components of both pairs are equal in magnitude. The components of both pairs are opposite in direction. So action-reaction forces are equal in magnitude and opposite in direction. So are balanced forces. They are equal in magnitude and opposite in direction. The difference is that action-reaction forces act on different objects, as we mentioned before, while balanced forces act on one object. So here in the image in front of you, you can see an example of balanced forces. They are acting on the same box, so they are acting on one object, not like action and reaction forces which act on different objects. So they act on the box and they cancel each other because they are opposite in direction and equal in magnitude. However, action-reaction forces do not cancel each other. Example: two girls, each on her skateboard, meet in the middle of the playground. Girl 1 pushes girl 2 with a force of 90 newtons to the right. The mass of the first girl and her skateboard is 60 kilograms. The mass of the second girl and her skateboard is 55 kilograms. What is the acceleration of each girl? In these kinds of questions, we need to separate the objects in order to find the acceleration or the force or the mass of each object. So girl 2 has a mass of 55 kilograms and the force acting on her is 90 newtons to the right. Acceleration, according to Newton's second law of motion, is force over mass. So 90 newtons over 55 kilograms equal to 1.63 meters per second squared. Now we find the acceleration of girl 1. Girl 1 has a mass of 60 kilograms and the force acting on her is minus 90 newtons to the left, opposite to the force acting on girl 1. Why? Because they are action and reaction forces. Girl 1 pushed girl 2 with an action force of 90 newtons to the right, and girl 1 receives a reaction force of minus 90 newtons because it is to the left. So acceleration is equal to F over m, force over mass, equal to minus 90 over 60 kilograms, which is equal to negative 1.5 meter per second squared. So the acceleration of girl 1 will be to the left, while the acceleration of girl 2 will be to the right, in the same direction as the force acting on the girls. Please, as a homework, solve numbers 6, 7, and 8, page 159, and numbers 16, 17, and 18, page 160. Thank you and good luck.